So, number 1, fundamentals of Minecraft modding, presented by It's Meow Dev. I haven't introduced myself. I'm Kat. I'm a third-year cybersecurity major. I've done modding for since I was 12. So I quit in mid 2023 because I got tired of it. Because when you make mods, people constantly ask you to update them, and I kind of got sick of it because I had 25 projects, and then every single time a new version would come out, I have to update all of them because people would be like, "Please update, please." I got tired of it, and I just wanted to free myself from having to do that every year. So I stopped modding, but I'm doing this as a way to get back into it. So I have caught myself up on the latest trends within the past year and put a lot of that into that presentation. So yeah, that's a little bit about me. My most popular mod you might have heard of is called Better Animals Plus. It has 20 million downloads. So that is my big flex there. So we're going to start with setting up a mod development environment because you can do this during the lecture because it's going to be really annoying. So if you haven't, please install JDK. Hold on, let me post the link to this presentation in the Discord for everyone so that if you want to click the links, you can. So if you don't have the JDK, download and install that on the presentation. It should just, first things first, that's the one thing you need. I said earlier you need 17 or higher. I think the newer versions of the Gradle plugins we're using need Java 21 or higher, so.
I think the current version of Minecraft also depends on 21.
No, the actual specification, language stack it uses is 17, but a lot of the Gradle plugins use 21 is what I figured out. So, yeah, so raise your hand if you don't have Gradle installed or JDK installed yet. Everyone has JDK? Cool. Great job, guys. Also install IntelliJ IDEA. Everyone have that?
No.
Install it.
Yeah. VS Code is fine.
A VS Code is not fine. It is not going to work. So IntelliJ will automatically run all the Gradle stuff you need, and generally has better support for everything. So you want IntelliJ. I've never even used VS Code to do Minecraft mods. I've used Eclipse, but Eclipse is kind of out of fashion. So yeah, install IntelliJ. The new one's really fancy. Hold on, look at this thing. They changed the UI and it's all modern looking.
The VS codification of IntelliJ.
It does. It looks like VS Code. So that's that. There's also this fun little plugin, which I haven't mentioned yet. There's a Minecraft mod development plugin for IntelliJ, and it'll automatically help you generate mappings and mixin related stuff. So I do recommend installing it. The easiest way, I'll show you. Easiest way to install it is if you go here on window, I think it's settings. And then plugins, you can search Minecraft mod development or Minecraft development, and then if it asks to search the internet, just press that and you can install it here. That is the easiest way to install it. So I'm gonna move on from that. We can go back to this later, so you guys take your time. So this, if you open the presentation, you can also pick a loader. I would recommend downloading the NeoForge Gradle. Just download it as a zip or clone it, whatever, if you're familiar with GitHub. Do that, and then you can open it with IntelliJ, which I can show you later. That is just set up for how to make a mod development environment. Very short, simple. I will help you guys with it later. So I'm going to go into my presentation part where I will be talking for a copiously long time about how Minecraft modding works. So how it works, what do the loaders actually do underneath, how are they modifying the game, and I'm going to go through some historical and reasoning for why it is the way it is today. So the earliest form of Minecraft modding was called jar modding. So the way this worked was you would have so all Minecraft or all jar files are basically just zips full of .class files. That's how Java programs compile. They turn into class files and in a big package, which is the jar file. And then so to actually edit the code of the game, what you would do is people would pre-package a collection of they would make essentially another jar file or a zip file, and then inside that would be the correct directory structure to replace some files inside the Minecraft jar. And then you would open the jar file with WinRAR or whatever, and then drag all the classes from the mod into the Minecraft one, and then it would replace everything inside there. And then when you started Minecraft, the classes would be replaced. Famously requires deleting meta-inf if you were around for when jar modding was popular. That is because meta-inf contains the signing information for the mod, or for Minecraft itself. So it wouldn't start unless the signature was valid, so you would delete the signature so that it didn't catch an invalid signature. But there's a couple issues with that. If two things wanted to edit one class, you can't do that. You would have, it just wouldn't work because you can only have one or the other. It's difficult to perform because you would have to open the jar file, drag stuff into it, and then you couldn't really do multiple very easily. And it requires you to decompile and then edit the Minecraft source and then compile it and then replace the jar if you wanted to actually make a mod. So it's kind of technically complicated. And there was also copyright issues because if you were distributing a mod, you were distributing compiled portions of Minecraft source code. And the more things you edited, the more portions of compiled Minecraft code you would redistribute. So copyright issues with that. So then there is patching. This is a slightly better way of doing it. So patching is a fancy way to denote in a general sense, not in the Minecraft sense, is a fancy way to denote the changes between two text files. So if you're familiar with Git at all, every single Git commit is actually just a patch file which describes the line changes between two versions of the source. And I put an example of a patch file right there. So that one's deleting every single line inside a file. And you can see it notes the actual index position of the part that's getting edited. And you can also see that it includes the actual text for what is being added or removed, as well as in real patch files, it'll show some around it. So patch files won't work if your source differs at all significantly from what the patch was made for. So if you have one thing, two things patching the same file and they're not based off of each other, it can run into conflict. So patches in Minecraft modding, so patches run on Java source files, so the actual source code rather than the class files like jar modding. So you have to decompile the game to actually write a patch, and they act on the source code. And you can't really edit class files obviously because they're Java bytecode, which I will explain what Java bytecode is in a minute. So in order to actually do a patch, the way you would actually work with it in modding would be you decompile the game, and then you have all of Minecraft's source code, and then you would make edits to it, generate a patch file for that, and then apply those patch files. And you could do this with multiple mods because patch files are a little less finicky because you can edit the same file as long as the same lines aren't changed. And then you recompile that, and then now you have new class files, and you can do jar modding with it. So the problem with that is you can't really make users do that patching step. So we'll get there. So this is Java bytecode. In case we're not familiar with the concept, so this is what a Java source code looks like in the top left here. This is for hello world, right? When you actually compile it, you get a class file, which is a binary file that looks like this. It's just a bunch of raw hex data, and then if you interpret that raw binary into basically the Java equivalent of assembly, you get a bunch of instructions that look like this, get static, and then invoke virtual. So system.out, this is a get, and then it loads this argument and then invokes the println method. So Java bytecode is very weird compared to source code. It's a little bit lower level. So here's what I was getting at with the issues with patching. So it requires specific text to exist at specific line numbers. You have to decompile the game. And when you make a patch, you have to your goal is to reduce the amount of Minecraft source files that you change, so it leads you to do hacky stuff. In Forge, a lot of what they do is putting single line things that inject a small amount of code as possible, because if you add more, it's more likely to conflict. And only one patch can exist on a given source line, which has more issues. So here's what I'm talking about. This is an actual patch within Forge's source code. So this is something that Minecraft Forge is doing as part of their API. So you'll see that as much as possible, they do very little changes. So this one, they take what was normally a Minecraft source thing, they add a wrapper to it, and then register it back the same way that it originally was. And this link here, if you want to look, this is all the patches that Minecraft Forge has in it. There's a lot. It patches a lot of the game. And so mods themselves don't actually do patching, usually. Only mod loaders, so I'll explain that as well. So introducing the concept of modding APIs and loaders. So back in the day, there was not mod loaders. So things were more prone to conflicts. But the idea of a mod loader is the mod loader does the actual patching of Minecraft itself. So all the changes to Minecraft source code are done by the loader. And then they provide an API that then lets you interact with Minecraft source code indirectly through it, so that you don't have to do any editing of Minecraft source code. So they patch a lot of areas that are used most common by mods, like life cycling, registering entities, that sort of thing. So the mod loader will actually pick up Minecraft mods and then run them for you and then give you APIs and stuff. So then you don't have to do it yourself. So the earliest mod loader was called Rizagumi's mod loader. If you've ever used this one, it is ancient. So it was mostly used before 1.6.2 and in Minecraft beta versions. It supports rendering, recipes, adding entities, GUI, smeltables, and fuel. That is self-described what it does. It's pretty limited, but it was a jar mod. So you would jar mod Rizagumi's mod loader, and then you would put mods in your mods folder, and then Rizagumi's mod loader would pick up your mods and then let you interact with it. So I've mentioned two distinct concepts, mod loaders and mod APIs. They're sort of the same thing. So Minecraft Forge, as for an example, is both a loader and an API, but they are distinct concepts. So a mod loader is something that takes your mods, third-party code, and then runs them, and it loads them. It is a mod loader. And they usually give a lot of utilities for interacting with fundamental lifecycle stuff, making mixins, access transformers, that sort of thing. While a modding API is a collection of code that lets you interact with Minecraft directly, lets you register things. It's usually so the modding API is the thing that is injected, while a mod loader is just a utility thing that loads stuff. So some examples: mod loader. Forge has its Forge mod loader, and Fabric has Fabric loader, which are distinct things from Minecraft Forge and Fabric API. It's more noticeable in Fabric because they actually package their API separately. So this is going to be very technically complex. Bear with me. You don't have to know how this works. And I'm basically doing this so that you can understand why things are the way they are. We will dive a lot deeper into Mixins specifically in later lessons. This is going to be a little confusing. So, a problem that is prevalent in Minecraft modding is, since you get the modding API to do all the patching work for you, all the modifying of Minecraft source code, sometimes they don't do what you want. They don't have an API for what you want. You need to edit Minecraft source code. And because in modern Minecraft, you don't users don't patch anymore, they install a mod loader, and then those load your mods. There still needs to be a way that you can edit Minecraft source code. And that way is not jar modding and it's not patching. It is what I'm about to go into, runtime bytecode editing. You can edit the actual source code of Minecraft while it is running with code written in Java. It is crazy. So in the past, that used to be through ASM and Coremods. Now we use Mixins.
On the fly, it just
Yes.
rewrites the bytes and
Yes.
executes it.
Sort of. It's complicated. So I'm going to talk about ASM. So ASM, also known as core modding, it uses ASM, which is a Java library. Like it's just a library that exists that is known for its ability to edit bytecode. So the mod loader usually manages the ASM stuff because it's very prone to, one, it's technically complicated, and two, it can break stuff. So the mod loader dispatches you and then tells you, here's what you can do. You can write here, you can write here. I've never worked with ASM myself, so I actually don't know that much about it. This is just my understanding of it. So, question, yes?
It's been over like more than 5 years, probably closer to 7 years since I've actually worked with ASM myself. And I will say it is a very big pain in the ass.
Yes. So ASM can still conflict if you write it badly. It's complex. It requires deep knowledge of Java bytecode because you actually write raw Java bytecode operations like the ones I showed earlier, like invoke special or whatever the heck. So here's what ASM looks like. It looks ugly. I don't know what it's doing. I'm going to be so for real. So I was told that this is what it's actually injecting at a specific line, like point in the code. I don't have the injection point shown, but in order to inject this expression, like Java source expression, you have to write all these opcodes. So people don't do this anymore, thank God. So introducing Mixins. So Mixins were made in like 2015, but they didn't get popular until Minecraft 1.13 came out. So before that, people used ASM and core modding, which are ugly. So Mixins is like ASM on crack. Basically, you can write ASM without actually knowing anything about assembly because it's all defined within Java source code. And the injection point system is like very robust. So you can actually pick out specific points in the code that to like, so say for example, you wanted to like wrap something like whenever a block was broken in Minecraft, right? If you wanted to run a bit of code. You could put an injection point at the top of like the block broken method. You could set the injection point to the very start of that method and then like just write a bunch of Java source code and then it would inject it right there. And the good thing about this is you can have multiple mixins on the same point. So if two people wrote a mixin to inject at the very top of the Minecraft block broken method, then they could both comfortably exist there and it wouldn't conflict. So that's what's cool about mixins. You can also enforce, like, I can be the only one that can edit this file, or you can replace entire functions. So that's how you modify Minecraft source code without patching, is mixins. And you don't need to know ASM, is the biggest upside, or bytecode. So this is what a mixin actually looks like. This is Fabric's furnace fuel registry. So if you wanted to register like a new like duration for a furnace fuel, this is the mixin that accomplishes that. So you can see right here, it injects at the return opcode inside the create fuel time map. So right before the function returns, it injects this bit of code, which calls the fuel registry, and then applies the return value to it. So basically, instead of returning the like Minecraft version of the fuel's like duration, it picks it up from Fabric's API and then replaces the result of this function with that. So yeah, mixins are very cool, very complicated. We'll go deeper into them in later lessons, not this one. So in modding APIs, mixins are actually pretty heavily used, especially in Fabric. So mixins are less susceptible to conflicts. They break less often than patches because they don't actually rely on the Java source code. So they count on specific like bytecode operations existing. So if you write a made mixin injection point, it's less likely to break between Minecraft versions because the function will still exist in some form. It doesn't actually rely on the source code. So say Mojang renamed some variable or something, or like restructured some code, the bytecode operation would still exist. so it's less likely to break. It's easier to use. So Fabric's API, the Fabric API, is almost entirely implemented in Mixins, as opposed to Forge, which implements their API through patches. So a lot of the loaders are moving to Mixins instead of using patches, even for their actual API implementation. And Fabric's loader uses ASM to inject a small amount of lifecycle code. I have to sit down. 1 sec. Any questions? Nope. Okay, so obfuscation. This is one big topic in Minecraft modding that's very helpful to understand. So when Mojang publishes the game, as in to end users, so when you play the game, you're playing an obfuscated version of the game. So the jar files that they publish for the game, they replace every single class name with basically gibberish so that you can't reverse engineer the game as easily. Because then any old person could just open up the Minecraft jar file and then read everything. In modern times, it's a little less relevant. We'll get there. But so they replace every single class with A in sequence. You can see this picture here. That's what the actual Minecraft jar file looks like inside. They also replace every single method name, field name, argument, local variable, package definition with basically gibberish. It's difficult to read and work with because nothing has a meaningful name. It's literally just logic, and the names change between Minecraft versions. They're sort of random. Not exactly random, but they're pretty random, which is also difficult because then every time the game updates, you're just resetting any knowledge you had. This is another example. This is what a decompiled, obfuscated class looks like. I forgot which class this is, but I think it's some type of packet. It's a packet that writes a short.
It's obviously class A.
Yes.
And it
so
implements UO.
it's very difficult to figure out what things are when you have this. So if you were back in the day and you wanted to write a Minecraft mod, this is what you'd have to work with. But luckily for us, we have something called mappings. So they used to be user developed, not anymore. Mojang released their actual mappings, but we used to modders actually used to come up with the names for things through extreme trial and error, finding more obvious things, moving from there. And then you would write those names in a big list that looks like that. This is actually Mojang's official one. Also, Mojang is a fucking troll. Void, you just lost the game. Thank you. That is in the official 1.19 mappings. They made a function. There's nothing in that function. It's literally gibberish. They just put it there at the top for funsies. So yeah, I would map all those gibberish names to meaningful ones. And so under the hood, everything still uses the obfuscated names, but when you're developing it, we translate everything to mapped space, and then you compile it, and it turns back into gibberish. And then the concept of intermediate mappings is also helpful to know. So because mappings change between every version, the raw gibberish to the name stuff, we have something called intermediate mappings, which go from raw gibberish to slightly less, more meaningful gibberish to actual words. So the slightly more meaningful gibberish is designed to stay the same between versions. So you would map the nonsense to the version stable version of itself, so the thing that will be the same between versions, and then the actual final one. So there are 3 intermediary systems. There's old SRGs, there's new SRGs which look like this, and then fabric intermediaries. The numbers are different between those two, so the same function would actually have different numbers. But it doesn't matter. So if you see something that looks like this, that's an intermediary. You work with those a lot more than you would the raw gibberish. So yeah, you can maintain the intermediaries by guessing, basically, because the code will look similar enough between versions that you can just remap the gibberish onto itself because the decompiled source is almost identical, unless Mojang does a bunch of changes. So mapping systems. There are a few mapping systems. The old ones are called MCP mappings, not the same as MCP the tool, which I will get to later. MCP mappings and Sarge intermediaries, or SRGs. So that's what Forge used to use a lot. And they're outdated, basically. They don't really maintain them anymore. And then there's Fabric's yarn mappings, which were made in 1.14, which is when Fabric came out. Similar idea, different names. So basically, between these systems, the names of everything in the Minecraft source code could vary drastically. So like, for example, there's like resource locations, which are like a fundamental thing in Minecraft that are used for like finding the asset path of things. In Fabric yarn mappings, they're called identifiers. But good thing is now everybody uses Mojang's official mappings, which they released in 2019. They just published the actual versions of their source code with the actual mappings. So now we don't have to make mappings anymore because Mojang was so nice and gave them to us. Thank you, Mojang. Except they also didn't include the argument names or local variable names. So now we have Parchment MC, which is an add-on for Mojang's mappings that re-adds parameter names and Java docs, which are comments. But they're community made because we don't have Mojang's actual ones. And then this is a tool called Linky. It can look up basically any mapping for any Minecraft version for any system. So if you ever have any questions about mappings, you can put in any function name and it will tell you all the intermediaries, all the things you need to know. It will also generate access wideners or access transformers and mixin targets, which are technical stuff that we'll get to in later lessons. So, modding APIs. I've talked about Rizagumi's mod loader, but these are the ones we actually use now. So Minecraft Forge. Minecraft Forge is the most prevalent API. It was the first one to actually replace jar modding in a meaningful manner other than Rizagumi's mod loader. It introduced the concept of like a built-in bootstrapper. So prior to Forge, you would actually have to install the mod loader yourself. But Forge has an installer and would actually perform patching on the Minecraft source code. So Rizagumi's mod loader, you would still have to replace the classes inside the jar, but Forge will perform, it'll apply a set of patches from the installation step. So that's convenient there. And Forge as a whole is monolithic in nature, so it will attempt to provide an API for literally everything you could possibly want so that you don't have to do any patching, which has a couple upsides and downsides. It runs on MCP mappings and SRG intermediary, although most people nowadays use Mojang official mappings. And it provides a lot of tertiary functions like mod GUI, like the mods list button in the Minecraft menu, config APIs, that sort of thing. So a lot of extra stuff. It has its own built-in energy API and item transfer APIs. It is famously developed by Lexmanos, the internet's most notably disliked Minecraft modder. He is a pain in the ass to work with. I have spoken to him on occasions and he has been pissed at me. I don't even remember why, because he is just that unlikable. Yes?
One could say he's responsible for the creation of 2 whole models.
Oh yes, we'll get there. We'll get there. We'll get there.
Yeah.
Yeah. And hyperbole, but he will ban you for discussing topics he doesn't like Fabric or core modding. Yeah, so we don't like Lexmanos in this house, but he is a person at the end of the day, so whatever. Notably also developed by CPW, who made some of the internals. So 1.13 era. This was a very turbulent time for Minecraft modding. Everything changed. So Mojang decided to rewrite the game in 1.13 basically. They took every single block and every single item and then split it all out into distinct versions. So before that, it used to be wool was 16 different metadatas of the same block. And then they decided to make every single wool block its own block. So then white wool would be its own block ID, red wool, and so on. And they did that for every single item in the game. And then they also rewrote significant portions of the world generation. So you'll notice if you play 1.12 and you play 1.13, Minecraft looks very different. So for Minecraft modders, this was very problematic. because when Mojang rewrites things, we have to rewrite things. And so Forge also took a brief pause to decide how to write themselves, and also took it as an opportunity to rewrite a lot of their old APIs. So it took a while for Forge to update, and by a while I mean a year, almost a year, which is extremely unusual. Usually it only takes around like 3 months max for people to make a new version of the loader. And so Fabric was in development during this time because people wanted a new loader. And then the only model loader that was actually used by most people for 1.13 was Rift. Nobody uses Rift. I couldn't tell you anything about Rift. I never used it, but it existed, and Fabric basically replaced the need for Rift. Fabric. So Fabric. Fabric is lightweight, modular, and community-oriented, as opposed to Forge being heavy, non-modular, and has Lexmanos. So it's like basically developed to be completely independent of Forge as a whole. It's the first mod loader to actually like rival Forge in any manner whatsoever. It has its own mapping system, Gradle plugins. It's implemented mostly using Mixins as opposed to patches. And Fabric API, notably, is also distinct from the loader, which I mentioned earlier. So like, you don't actually need the API to run Fabric mods, technically. Most people in practice do use the Fabric API, but that's different from Forge, where you can't really just have the Forge mod loader. You have to have the API. So it can update a lot faster than Forge, mostly because it uses the mix-ins, and then it's modular, so you can update only modules at a time. If you open the Fabric like source code, you'll notice every single part of the API is in different API modules. So that's one perk there. One of the downsides of Fabric is it has a lot less like extra stuff. So like there's no config API. And this can lead to a lot of conflicting standards because modders make their own config APIs, right? So there's actually like 4 major config APIs that people use: cloth config, midnight lib, forge config's API port, and auto config. And so like all these are like different versions of the same thing. And it requires a lot more dependency. So if you've ever used like Node.js, it's like dependency hell sometimes. But Fabric's cool. And one other thing people do is called multi-loader development. So Forge and Fabric, very different things. Minecraft mod users love having as many versions of the same thing as possible. They like new Minecraft versions. They like having choices, playing Forge and Fabric. But developers really hate maintaining those. So the solution is to make both versions at the same time. So if you think about it, if you're using both Forge and Fabric, there's going to be a lot of code that's like almost the same thing but slightly different, and is like shared between the two. So people make like fancy Gradle projects where you can have like shared code and then loader specific code that does like the registration stuff. So people do that a lot. And then there's also Architecture, which is a step above the multi-loader system, where Architecture implements an API that is an API for the APIs. So Architecture has a version that runs on both Forge and Fabric. It's like written to interact with both Forge and Fabric. And then your mod interacts with Architecture, and then Architecture's like API layer has an implementation written for Forge and an implementation written for Fabric, and abstracts between the two. So then you write your mod for Architecture, and then Architecture does all the communication with APIs. So it's really interesting. So that's what I've used that a lot, actually. I've used this a lot. You can write a mod for both Forge and Fabric at the same time and have like a ton of common code. Very cool. And then NeoForge. So, yes?
Doesn't this just seem like the whole XKCD competing standards
comic? It's in here.
Oh.
Here it is.
I predicted this.
Here it is, guys. How standards proliferate.
All right, back to NeoForge.
Yes. So NeoForge. Remember how everyone didn't like Lex? Yeah. Well, this happened like a year ago, a year and a half. Everyone didn't like Lex so much. They got so fed up with this shit that all of the Forge community members, like 90% of them, except like 2, jumped ship and made their own project. And so there's NeoForge now, which is the same thing as Forge, almost. So in 120.1, they're the same thing. In 121 and up, they're not the same thing. So NeoForge is a little different. has its own like ecosystem now because they have to be legally distinct from Forge because Lex still owns the Forge brand. So NeoForge is basically Forge, but no Lex. So people use that now instead of Forge for newer versions of Minecraft. It's basically entirely replaced Forge. So that's cool. Here's this comic, which, yes, aptly timed.
And architecture does Forge or NeoForge?
NeoForge, well, both. Like, so prior to 120, like 120.1 and lower, Forge. 121 and higher, NeoForge. Which is how most people do it anyway. We're almost done, guys, I swear. I have like 2 more sections. So, the modding development toolchain. So these are the tools that actually let you do the development, because otherwise you'd be like struggling to write class files and such. So, Mod Coder Pack, also known as Minecraft Coder Pack. This was a historical thing that people used to do before modding APIs existed. It was a tool that lets you decompile Minecraft, deobfuscate it, apply mappings, reobfuscate it, and then generate patch files and compile the Minecraft source, run it with different mods. So if you wanted to write a mod without using any modding APIs, this is how you do it. But it's not maintained anymore. It's ancient. People don't use this. Gradle. Gradle is just a general like Java tool. So a lot of Java developers use Gradle. But in Minecraft, it's very important. Yes, Gradle fan over here.
No.
Not a Gradle fan?
I've never used it.
Oh.
I use Maven.
Okay, well,
Fuck
Gradle's
Maven.
better than Maven. So Gradle is basically like a fancy build setup system where you can specify how to like compile things in the correct manner, apply metadata, list dependencies, download dependencies. It's basically like NPM for the Node ecosystem, but better. So, and then every single ecosystem, every single like modding ecosystem, so Forge, NeoForge, Fabric, they have their own like Gradle plugin, which does all the like modding stuff, the modding specific stuff. So applying mappings, loading your mod like into the game, generating the IDE configuration files that let you run the game. So all that is handled by these plugins, which are Forge Gradle, Neo Gradle, also Mod Dev Gradle, which is the same thing, slightly different, and then Loom, which is Fabric's version of it. Yeah, so they all do basically the same thing, which lets you generate the configuration files and stuff. And then there's the Maven repository system, which is different from the Maven build system that Dustin was just complaining about. So the Maven repository system is just a way of like notating the format in which things are like stored on a web server, so that you can like access dependencies in a standardized manner. So you'll notice a bit of this inside Gradle Buildscripts. They make these GAV, group artifact version things, which are the specific path to something on a server. So this one, net Minecraft Forge, is the group, Forge is the artifact, and then this is the version. And then that redirects to the standard like URL, because this is the repository it's stored on, and these GAVs go in that specific order. So that's how like build scripts notate where to like download dependencies from. And that's where like you'll download Forge, all with those GAV paths.
Still Maven.
Okay, guys, structure of a Minecraft mod. Yes, we're finally here, almost done. So what a Minecraft mod actually looks like, the contents of a Minecraft mod. The skeleton, basically. So every Minecraft mod has a loader-specific mod configuration file, which contains metadata about your mod, such as the mod ID. This is very important. Very important. That's what uniquely identifies your mod to the loader. The version, any dependencies on other mods, what your dependency on the API is, so what versions of the API it requires. Authors, your title and description, or the name. Licensing information, and any links to third-party stuff, so like an issue tracker, your website, that sort of thing. So in Forge, it's the mods.toml. In NeoForge, it's neoforge.mods.toml. Like I said, same thing, but slightly different. Just enough to be legally distinct. And then in Fabric, it's the fabric.mod.json. And those links are all example files. for what they look like. This one that I've screenshotted here is for my mod Whisperwoods. It is a mods.toml for Forge. So that's what a mods.toml looks like. And then you have your entry point. So the entry point is the main area in which your mod starts from. So this is what the loader will find and then execute, and it starts off literally everything else. So if you want to register items, it all comes from here, that sort of thing. So it's the central class file associated with your mod. It's used to dispatch events. So in Forge, it uses this @mod annotation at the top of this class here, you can see. And then that identifies that class as like your mod's main class file. The mod ID is what is important here. It identifies, like, it matches it with your mods.toml file. In Fabric, you have the mod initializer, which is an interface that you have to implement. And then Fabric, to identify which one, like from your fabric.mod.json, you have to put the path to that file, the class file, rather than putting an annotation or anything like that. So you put that inside the entry points definition there. And then another part of Minecraft mods are event buses and their subscribers. So say you want to have a specific set of code run every time the world is loaded. That's a pretty common use case, so most modding APIs will already have something for that. You wouldn't have to write a mixin. So the modding APIs provide an event bus where you can tell it to dispatch events to a method. And those events would contain information about the type of the event and any thing that's going on. So if the event was the world has loaded, then it would include a copy of the world file so that you can view any data on it. Or it would tell you what the name of the world is, for example. And then within your listener or the subscriber function, you could maybe edit those fields or call methods on the world, that sort of thing. Or you could cancel the event sometimes, which will prevent something from occurring. So that's what an event bus is. Registries. This is a very important concept in Minecraft modding. So if you wanted to add a block or item to the game, you need to add it to a registry. It's how the game keeps track of what items and blocks exist in the code, and it's what associates IDs with actual content. So logic and IDs. This is what associates them together. So you add it to a registry. And then there's a concept called registry objects, which are just the static field that holds both the key and the content itself together, so that you can reference it from other stuff. So if you wanted to get a copy of the Minecraft apple item and then call the eat function on it, then you would do items.apple, and that is a registry object, that apple field. You wouldn't actually call the eat function. Say you wanted to spawn an apple, then you would pass items.apple to the function that drops stuff. And then content classes. So these are the actual classes that implement logic for things. So the apple is an instance of the food class, right? And then the food class defines how much saturation, how much hunger that fulfills. So each instance is then associated with registry objects. So the content classes actually hold the logic that does things. And there's basic types that you can extend from. So a block, item, entity. So food extends item, which extends just nothing. So then you add these to registries, instances of them. Resource packs. This is the same as a texture pack for Minecraft, but your mod basically has its own internal one. This is also how Minecraft itself processes things. So if you want to associate textures, JSON models, block state definitions, language files, sounds, that sort of thing with your mod, then you put it in your mod's resource pack. And then you have the standardized resource locations system, which is used to reference those assets inside your resource pack. I did describe this a little bit earlier with the identifier thing from Fabric. So this is an example of a resource location. It has a domain, which would in this case is Minecraft, and then a path, which is this part, so textures, item, stick. And then that associates with an actual path inside your assets folder, which is assets, Minecraft, textures, item, stick. So for your mod, if you had any assets, it would go inside your mod ID as the domain. So that's the importance of the mod ID there. And you reference them in code to associate resources with things. Data pack, same thing. but it holds anything that's not like textures, basically, so like actual logical stuff. Minecraft as a whole is sort of moving towards data packs to replace a lot of like registry sort of content. So like crafting recipes, smelting recipes, any loot that you spawn. Newly, which is interesting, damage types. So like lava damage versus fall damage. They're stored as data packs. It's really weird. Structure definition files go in here. So data packs hold all that like weird third-party data stuff. They're also referenced with resource locations. So basically, Minecraft as a whole is trying to move away from. They're trying to make the game moddable through data packs rather than through APIs. But modders don't really give a shit about that. They just use the data packs. So that is it for my like actual presentation for Minecraft mods. Here are some Java concepts that are important in modding that you should know. If you aren't familiar with a lot of these, you should brush up on them. Lambdas. These are inline function definitions. They use this arrow notation here. And there's these different types that are associated with lambdas that you should know how to use. And method reference syntax is good to know. And interfaces. They're interfaces. I don't know how else to explain them. You should know these. They're good to know for Minecraft modding. Generics are a little bit complicated, but also useful to know. You might not really need to write generics, but you should know how to use them. And annotations, which you just need to know how to use. It's very easy to learn by example, so no worries there. That is everything I prepared. My 57 slides.
57 slides.
Yes. If anyone in the audience has any questions, feel free. Any of you? Go for it.
So I just realized that the reason I bounced off of modding was because I did a lot of my modding at 1.7 or before 1.7 before everything was made convenient. And then near the very end when I just stopped was when, I don't remember the context, and honestly it was probably Lex in retrospect, who was basically going like, no, you should never, ever need to do a core mod.
Oh yeah, Lex hates core mods. He despises them.
Like, I literally cannot have Snow be passable in this version without a core mod. Can I get some help? No. Okay.
No, they will not help you with core mods. That's why I never learned.
Yeah. And I think that actually like killed my like doing modding for a while.
Yep. Any other questions or comments or such? We're gonna move to the workshop part then.
About, like,
yes, where we will. So the first thing we're gonna do is make a mod that registers something. Or no, here's what we're gonna do. We're gonna make it so we're gonna listen to an event, and when that event occurs, it's gonna do something. All right, guys. It sounds very simple, but it's gonna be annoying.
I'll be right back.
Okay, so I did test this out beforehand, guys. So everyone has the JDK, right? Yes, JDK, IntelliJ, and a copy of some MDK. Do you have the MDK downloaded? I linked the NeoForge MDK one. Hold on. Yep. So. This one, yes, NeoForge. So if you hit, where is it? Code, download zip, right here.
In that extension, I need to install. Oh wait, no, I need to.
You don't need it, but yeah, you can. You can do that after you download the MDK. So if you download the zip there, then just extract it. Okay. So everyone should have this. Just a folder with a bunch of random crap in it. Everyone got that? Okay. And then if you have IntelliJ, just open IntelliJ. So it should actually open. Hold on. Yeah, it should open to this screen, and then you just hit open, and then you need the you want to open the build.gradle file inside your. Why isn't it? Hold on. Hello. Hold on. That's not what I wanted. Yes. Okay, if you can tell it to open the build.gradle, and then it'll ask if you want to open it as a project or as like a file, open it as a project. So once you do that, oh, why did it do this? No. That is not correct. Hold on. Why is it doing this? There we go. Okay. I need to delete this .idea folder though. So yeah, here we go. So if you open the build.gradle file, and then it'll ask you if you want to open it as a project or a file, click as a project, and then it should automatically start the import process, which looks like this. It's this thing down here. And so if you hit the build thing here, you can see the progress of it like configuring. So just make sure that build successfully completes. So what this is doing right now is it's downloading the Minecraft source code as well as NeoForge. It's decompiling it and then applying the patches required to like modify it, and then it's deobfuscating it, so it's applying mappings to it. And then it's making all the like necessary like source sets so that IntelliJ can actually view and interact with the Minecraft source code like through the IDE. So the cool thing about modding is you don't actually need to know most of the stuff in my presentation. It's just very useful to know, because when stuff breaks, and it inevitably will, you know how it works. So you know why it's breaking. And there's a lot of words. A lot of fancy words that are confusing that it's good to know those for. So mine just finished loading. It only took like 30 seconds because I've already decompiled the game recently.
How do you load the Minecraft?
Let's see.
Seems mine's already done.
Yeah, I've opened.
Click that just to. That's how you check the progress.
Oh yeah.
It is. Click that part. Yep. It's fine. It's just taking a second.
Okay.
Right there.
Oh.
Yep. So it's running. Is everyone online getting along with this okay? Feel free to just drop in the chat here. You got it? You got an error? Oh.
Yeah, me too.
Your Gradle is using the wrong version. Here, okay. So if you have multiple versions of Java installed, sometimes your IDE will pick up the wrong one. So if you click here in the top left, File, and then go to Settings, which is this one, or Control-S. Everyone got that? File, Settings. Okay. You got this menu? You got the menu up? This one? Okay. So then under Build, Execution, Deployment, and then Build Tools, there's the Gradle section here. Open that. And then you need to change the Gradle JVM here to 21. If you have a 21 version. If it's on, yeah, what's it on? Yeah, that's the problem. So once you do that, hit OK. And then click this little refresh icon right here in the build section right here. Reload Gradle project, and then it'll rerun it. Oh yeah, if it asks you to like elevate for Windows Defender, just hit yes.
Trust.
Is it going?
It's going.
Is it going?
I just hit open.
Oh, you just opened it?
Yeah.
Come on. You're going good?
Well, if I too fast, I'm curious whether or not I actually compiled the right thing.
Well, if your source sets exist?
And is it actually created a test?
Yes. They do. Cool.
Great.
Yes, so you need to do what I just showed, I think.
Wait, what?
Yeah, click that. That one's new. I haven't seen that one before.
Not really
Change
good.
that. 22. Just hit delete press that. Install the JDK.
I think we're going here.
Cool. So once yours completes, then I can get started with the next section. So let me know if if yours is done. Done. No wait, you're not done yet. Are yours 3? All yours are done?
Still loading.
Still loading? Okay. Yeah, it might take a bit. It can take up to 5 minutes.
5 minutes, 15 seconds.
Yeah, it can take up to like sometimes 15. It depends on your computer.
I think I probably did the whole decompiling thing while you were doing the presentation.
Yes, that is why I put that part of the start. I know it was probably going to be a little too rushed though. It's better to just get the stuff downloaded, which everyone did. So great job, guys, for downloading JDK. What's up?
Yeah, okay, so the files in the source folder are actually present in the original zip that is available, and those files are not being produced when I rebuild. When I build, the source folder is empty, and in the actual zip, it extracts the files.
What?
Yep.
That didn't make any sense.
No, it doesn't.
Are you sure you opened it properly?
I can.
Is your like disk malfunctioning or something?
Shouldn't be, but I'm not seeing any other issues which would have indicated such.
Hit Gradle here, and then refresh. Okay, remake the project. What the hell? Do a clean build. So if you do in a terminal, open the terminal thing here. Gradle W space clean, and then space minus no build minus refresh dash dependencies. Yeah, try that. Oh, your wrapper's not. What? Try. Oh, I don't know. Delete that folder and then re-extract it and reopen it.
Okay.
I will say this build file looks a lot more readable than I made at the prom.
Oh yeah. So while we're waiting for that to load, we can take a look at the build script. So everyone open build.gradle. It should be in there under the project. So The fun thing about these little build.gradles, let me minimize that. So this is the thing that actually like assembles your Minecraft stuff. And you can configure a lot of the basic settings of your Minecraft mods. I think these are one of the most neglected things in Minecraft modding because people aren't comfortable with Gradle. But the main thing to know is that the actual Gradle file is what templates a lot of the stuff. So if you open source templates and then the Neoforge mods.toml file, you'll see a lot of these like weird like templating things. Like the mod ID doesn't actually have your mod's ID, it just has this template. So your build script is actually replacing these with the ones defined inside the build script. You can see that, let's see, right here, replace properties. So it has all these templates for the mod metadata and it replaces them. So fun there, but they're actually defined inside Gradle.properties. So this is the part that actually configures your Minecraft mods like metadata instead of the mods.toml in newer Neoforge projects. It's all in Gradle.properties, so I recommend looking in there. And if you ever wanted to say update your Minecraft version, it's also in here. And the Neoforge version, so I think this is the latest one, but you can download newer ones. If you go on the Neoforge website, the latest one is 21.1.42. This is 21.1.35, so I can change this to 4.2. And then if I go to Gradle here on the right and then hit refresh, it will download the new one, which is what it's doing now. And look at that, it's going. Applying the new patches. Sorry, Code Chicken? He's still around? That's crazy. Code Chicken made the original Not Enough Items.
Matt, were you around for Too Many Items?
Yes.
Oh man, that was
Peak.
I messed with that back in the day.
How much storage do I need for this?
How much storage for a Minecraft mod? Usually a project for the like modding will take up at least 1 gigabyte.
Just the import.
Yeah, the import usually takes up a little bit. Hold on. The cache, oh, that's not bad. Usually they take up more. The actual like shared Gradle cache on your user takes up more space usually.
And 0 bytes for 8 bytes
Hold on. This like shared cache in your user folder usually takes up more. Yeah, look, see? I have 2 gigabytes of crap in my Gradle cache. So, okay, I think everyone's projects are ready now. Lucas? Aubrey? No?
No space. No, it's my issue.
You're out of space,
Yeah,
actually?
I'm out of storage space on my
What? So what the hell is going on with this?
Okay, so I renamed the extracted folder in source to be able to differentiate it for when main is reconstructed by build. And wait, I'm an idiot. Whoops. We're looking in the wrong folder.
Why are you building it? You weren't supposed to build it. Hold on, can I?
Yep.
Oracle movement.
Well, I do think files have changed and built. LivingEntity has not been modified since it's been unzipped.
There. You're running the wrong one. You need to run safe not build.
Cool.
Alright, all done.
Thank you.
Oh, I need to plug in my computer. That would be important. I didn't realize it wasn't plugged in. Alright, we are ready now to do our first mod. Once I get this plugged in. Youch. Alright, guys. So, everyone's project should work now. If you open source main Java, this is where the actual mod's source code is.
Oh Lord.
Yeah, so Forge puts a bunch of random crap in here. You can press minimize here to hide this. So Forge puts a bunch of random crap. We're going to thin this out so that we don't have to, so we can write our own. So delete basically all of this, so everything from add creative and below. Nuke it. All of this, nuke.
What line is that?
109 to 135. We're also going to delete the config file. This one called config. Delete all of this here inside common setup except for the log there. And then delete all of this. So everything except the first line of the constructor here. And then delete all of this. So your file should look like this. And then you should have deleted config. So that's how we're gonna thin out the example mod. This is what example mods used to look like. Now they add a bunch of random crap for you, but it's more fun this way. So. Basically, we just want to get comfortable with the structure of a Minecraft mod right now. So in my presentation, I went over a lot of this stuff, but it's good to like see it yourself. So the first thing is inside the templates meta-inf folder, you have the neoforge.mods.toml, right? This contains all your mods metadata, including a dependency on Neoforge, dependency on Minecraft. And then number one, your mod ID, right? So the mod ID is the most important metadata associated with your Minecraft mod.
Can you turn out the lights? I cannot see that.
Or just zooming in a lot more, maybe.
Or you can like make the lights dimmer.
Yeah. There's also the screens have better contrast, if you can see those.
Yeah, that's fine.
Okay. Okay, yeah, so the mod ID here is the most important part of your Minecraft mod, metadata-wise. It's inside the templates folder, right? The templates are generated by your build script right here, this generate mod metadata task. So it replaces the mod IDs with the mod ID variable in Gradle. The mod ID variable in Gradle is defined inside Gradle.properties. So this is what actually ends up in your mods.toml, is this mod ID defined right here in Gradle.properties, right? So what's important about Neoforge mod specifically is that this mod ID matches the one that goes right here. So the actual mod, like entry point class, has a @mod annotation, which is a Forge thing. So I could remove this and put it on literally any other class, and then that class would become the entry point for the mod. So if I just made example mod 2, right? And then I added an @mod annotation with example mod 2 as the mod ID, then this would be a separate mod, basically, except it doesn't have a mods.toml, so it wouldn't load. But if I went in here and then changed this to example mod 2, then this would be the only one that loads, because it's the one with the matching annotation. So that's what this is, except instead of using a string constant that contains like the mod ID, like this, we're just referencing this variable here. So it makes it a little easier because then if you want to use your mod ID, you can just reference that instead. Or if you wanted to change it, then I could just do that. So I'm going to put this all back to normal now because I don't actually want to change it. But for first things demonstration, yes.
Yeah, so what if we want to like have 2 or more mods?
Inside one project,
Yeah.
that's not very common. You can define multiple mods inside, I think, Neo4. Yeah, so you can make additional mod entries like this. So I could do like mods, but people don't do that usually. You make another project, so it would be like a subfolder. You can do some fancy Gradle stuff, but so I think everyone's first task is to change their mod ID. So I'm going to name my mod catmod, and then change the name of it to catmod. So open your Gradle.properties and change your mod ID to cat or whatever you want. And then I'm going to change my author to cat. In the description, this is a really cool mod. So when you change your mod ID in the Gradle properties, you also need to change it inside your code. So if I go right here, I need to change this one to match. Otherwise, my mod will not load. So those are the only things that actually matter when it comes to your mod's like ID. But there's a couple other things. So like, for example, the package is still like example mod. So you might want to change that. So you could rename. So right click the folder and hit refactor, rename. And I could do dev.itsmeow.catmod. And just like that, I have changed the directory. I could also change this one, the name of the class, to catmod. So just like that, I have rebranded my mod from the example. So you'll notice also that when you change the mod ID, we also need to update the asset like stuff. So like we're not actually using these, but all the assets include example mod as part of the mod ID. So yeah, the mod ID is a very important part of a Minecraft mod. I'm actually going to delete this. What's up?
Can you edit the class name and like at the same time it just like automatically edits?
Right click it, right click the name of the class anywhere, and then hit refactor and then rename.
Oh.
Hooray for IntelliJ. And then you just start typing and it'll replace it everywhere, and then when you're done you hit enter and it'll update it.
How do I rename this, the assets?
You can just delete it. We don't need it. We're not actually using that. And then the last thing associated with like the mod ID is this mod group ID. It's used for publishing on Maven, like the Maven repository system I described in the presentation. So it usually just matches your package name, but it's not very important since we won't be publishing on Maven. So just like that, we've changed our mod ID. If you do like major changes like that, you usually have to sync with Gradle to like rebuild the source sets. So if you hit Gradle here, and then this refresh icon, it will start a reload task on the bottom. You can also press this one under sync. They both do the same thing, so this is the same thing. So everyone's mod should have this common setup thing which says hello from common setup. Everyone have this?
Yep.
Great. And has everyone updated their mod ID successfully? Everyone's ready? Okay, well.
Yeah. But I think I have some Gradle issues, but
What's up?
not enough memory.
Right. Open Gradle.properties.
Okay.
Yeah, I should probably
Change
do that.
the XMX at the top. Well, Change that to 4. 4G. Capital G. Capital G. Yeah. Now refresh.
I'll just give it 16 for the fun.
Don't do that. Do not do that. Bad idea. Okay, so
32 gigs.
if you want to make your mod load, your like things load faster, if you open Gradle.properties, you'll notice this. This is the amount of RAM allocated to the Gradle task. It goes faster if you give it more. So I'm usually give it 4 gigabytes of RAM, and that makes it run faster. So then when you press sync, it'll have more memory to work with. Especially for decompiling Minecraft, it's very useful to have more RAM. So that is my pro tip there.
Does the mod ID have to match the class name?
No, it does not have to match, but if you want it to match, you can make it match, which I usually like making it match. So once you have updated your mod ID, we can actually run the mod from within Gradle, or within IntelliJ, and then it'll start Minecraft. So if you go to the top right here, you can see this little drop down. If you hit client, then it will let you select run or debug. We can just hit run. And then if you hit this icon here in the bottom left, the run icon, it'll show you like the current run job. So this is where the actual like Minecraft client log will output. You can see it here. So what we're going to watch out for is the hello from common setup that we specified here. That means that our mod is actually getting loaded into the game. There it is, right here. dev.itsmeow.catmod. Hello from common setup. And just like
Press
that.
enter to enable the narrator.
Just like that, we have modded Minecraft. Look at that. Cat mod.
That's fun.
Everyone have this?
I don't think I hit save on that Gradle change, so
Huh?
I just hit restart again because I don't think I had save.
What's going on? You've updated your example. Yep. That looks good. No, that all looks correct. So if you go up here, no, current file, define it.
I just realized that the spinning thing in the main menu doesn't go at a constant speed. It just randomly slows down and then it speeds up.
Yeah, if you hit control
Like it slows down and then
Alt,
it gradually speeds back up a little bit.
Control Alt O. I guess not. I guess not.
Like the spinning like world background.
You got it. Nice.
It doesn't move at a constant speed. And that bugs me.
Yours working?
Oh yeah, I'm currently.
Did it run?
Yeah, right.
Awesome.
I saw that mods are.
You're making an event?
Uh,
Awesome.
Yeah, memory.
Actually,
oh, did you change
I'm gonna
it?
do that real quick actually.
Oh,
So,
you did, right? So you have to change it. So exactly what? Oh, it has to.
you don't have to change that,
Oh no.
but you can. So, yeah, that's actually correct. It's either
I mean,
this
it
or
went away
that
now
change,
because I
which
just,
is
it'll pop up again.
Looks good. Yeah, that's all correct.
How do I run this?
So click current file, and choose client, hit run. Boom.
I'm still getting a memory error, but it said something.
Do you
about
have
being
enough
too
memory?
small.
How much RAM does your computer have?
It has 8.
Yeah, that should be enough.
So then I tried changing it to 2 gigabytes.
Try it on. No, it's running. It's running. I'm just taking a bit. Yeah, your computer might not be powerful enough for this.
I was thinking about that, I was like, because it's definitely not going to run Minecraft at the same time.
Yeah. Okay, so everyone's mod has shown up in the mods menu, I hope. Cool. So, now I'm going to teach you guys how to figure out some stuff on your own, because that Minecraft modding is all about self-learning. Like I taught myself, most modders teach themselves. So the key to Minecraft modding is called reading the documentation. This has gotten better over time. The old Forge docs are terrible. But NeoForge, I believe, has better documentation. So if you go on the NeoForge website, there's this documentation link. And this describes everything about the NeoForge modding API. So it also basically just taught you what I just showed you. So customizing your mod by editing Gradle.properties, building and testing your mod, running on the server, that sort of thing, right? Structures of a mod. So packages, naming schemes, that sort of thing. So the concept of registries. So yeah, and there's a lot of really good stuff on here. So the first thing we're going to do is register our own event. So we will open the event page and then see what their documentation on registering event handlers looks like. So the first way it recommends is through this add listener. So if you actually look at your existing mod, it's already sort of doing this. So NeoForge and Forge they actually have 2 event buses. I'm going to close this. So they actually have 2 event buses. One is called the mod bus, which dispatches lifecycle events to your mod itself. And then there's the event bus, which is used for dispatching events from the game to your mod. So the common setup event is a mod bus event. And you can tell because it's prefixed with FML, which is Forge Mod Loader, not fuck my life. So Forge Mod Loader common setup event is a mod bus event. So the mod bus is passed to the constructor. The game bus is in a different place. It's at Minecraft Forge, or is it NeoForge? Yeah, it's NeoForge. On actual Forge is Minecraft Forge, neoforge.eventBus. So this stores the actual event bus, and then you can register listeners to it. So like I said in my Java review, this is called a method reference here. It's basically a fancy way of passing a method as an argument. So this one that adds a listener is passing this as an argument to another function. So that's the way it recommends. That is not my favorite way to run events. That's the first one. So the other one is the subscribe event annotation. This one's really cool. So you can actually, this one's a good, yeah, we'll do the living chump event actually. So if you were to make an event, they need to be static. Usually do public static void on block or on right click. How about that? So we're going to make it so every time you right click while holding a stick, it does something. So you can see it's actually recommending the event already. It's player interact event. That is the one. So you pass the event as an argument, the event itself, and that's what tells Forge what kind of event you want to listen to. And then as you can see in the documentation, it says you put the subscribe event here. So then you can just put @subscribe event. And that tells NeoForge that this is intended to listen to an event. The problem with that is NeoForge still won't pick up on this as existing, because the way it works basically, those annotations, is it tries to pick up every single class that could contain event listeners and then look for methods that have a subscribe event. We need to tell NeoForge that our class actually has event listeners in it. So the way you do that is by putting @mod.eventBusSubscriber. Or did they get rid of that? Hold on. Here it is, @eventBusSubscriber. Which is another annotation, and that goes on the class itself. If you look at the documentation here, it says, annotate a class which will be subscribed to an event bus at mod construction time. Defaults to subscribing the current mod ID to the event bus on both sides. So you can actually change the bus on this to the mod bus, but we actually want the game bus, which is the default, so we can just leave it like that. The one thing with these annotation-based subscribers is the listeners have to be static, because, if you guys understand the concept of staticness in Java, static means it's associated with the class rather than an instance of the class. So because the annotation is on the class itself, it doesn't know of any instances that exist, so we need a static version. If I were to remove static, it would error. At least when I run it, it would error. So we need this to be static. So now it will pick up any right clicks, right? The event has a bunch of data on it. So if you look, you can get the item stack, which hand, the direction you're facing, the position that it's occurring at, right? So if we wanted to check that the item we're holding is a stick, we can do event.getItemStack, because that's the current stack that you're holding. So an item stack is a collection of items that is instanced. So any slot contains an item stack rather than an item, because you can have multiple of one item, right? So that's what item stacks are used. So an item stack always has a type of item you're holding. So if you do .getItem, it has you can get the actual item. And so the item is always an instance of a registry object, like I described earlier. So if you want to check the type of the item, you don't do instance of stick item. That's not a good idea. Or you do == items.stick, because it's always this one instance. Blocks and items in Minecraft are singletons. It's a little confusing if you think about it, but items and blocks don't store data, right? They don't actually have data associated with them that isn't on something else. So a stick has nothing unique about it compared to every other stick in the game. They're the same thing. They have the same logic. They do the same things. Any special data that would be attached to it would actually be attached to the item stack, not the item. So the item class itself, the thing that holds the logic for the stick, is always just, there's only one item associated, one instance of that. So that makes it a singleton. If you actually right-click on the stick here, hit go to, and then implementation, right? It will decompile the class. If I give it time, I believe the sources should exist. There we go. So this is what Minecraft's actual source code looks like for the items file. It just has a giant list of every item in the game. So we're going to look for the stick. Here it is. So this is the stick. So you'll notice that the stick is actually not special at all. It is literally just an instance of the base item class. It has nothing special about it. So the only way to check if something is a stick is by checking if it is equal to this exact instance of stick. So anyway, that's my little tangent there. So that's how you check if something that you're holding is a stick. So if the item that is right-clicked is a stick, then what will we do? How about we, what do you guys think? What do you want to happen when you right-click the stick? What? You blow up? Okay, we can do that. So let me think about how you do explosions. Here's what I always do when I don't know how to do something in Minecraft. I think about something that already exists that does that, and I go look at its code. So TNT. Yeah, so TNT, we're going to look for TNT. So my favorite thing to do is just start typing. Look, TNT block, right? So if I autocomplete that and hit go to implementation, boom, we found the TNT block. This is it. So here it is calling the explode function, and then go to implementation. It spawns a prime TNT. Okay, well, I don't want to spawn a prime TNT, so I'm going to actually look at the prime TNT and see how that explodes. Here it is, explode. It calls this .level.explode. So levels are the actual world itself. In Minecraft, the level is the world. So I'm going to copy this code here, all of it. I'm going to paste it right here. We don't have a level on this. That we would get that from the event. So if I do get level, there's the level, right? And I can call explode. The source needs to be this entity, does it? So if I go to the implementation of the explode function, this one requires an entity, but we don't have an entity. So we're going to do it, try and find one that doesn't require an entity. actually, so you'll notice the entity is nullable. We're going to use this version of the function because it looks simpler. So if I just pass null, and then we don't need this, and we don't need this, we just need a position. So we can do get position. Actually, that's the position of the click. Do we want to explode at the player or wherever you click? Okay, so get pos dot get x, and then we need to pass get y, and then let's see, what was the function like? We need a radius, which will be 4, and the explosion interaction, which is TNT, mob, or block, or trigger. We're going to go with trigger. I missed a comma there. Boom. So that should do an explosion. And then
Can you show one more time how you go inside of each function?
yeah, so the first thing I did was type TNT block and then hit tab to like auto import it, right? If you right click the name, hover over go to and then implementations, it will take you there. And then I just looked around for explosions. Here's the part that explodes it. It spawns a prime TNT, is what the block does. So I go to the prime TNT, and then I look for the prime TNT where the prime TNT actually explodes.
What does prime TNT mean?
So when you actually light a TNT on fire, it actually turns into a movable version, right? Remember, like you can launch TNT and stuff? So a prime TNT is actually an entity, it's not a block. And so you can actually, if you boot up the game, you can spawn like prime TNT entities, and then they'll just explode after a couple seconds. So that's what it's primed, like it's ready to explode. So prime TNT has the explode function, which calls this on the world's, like the level. Let's see. Yeah, so scroll down. Keep scrolling. There. Yep, that's it. So if you right click that and hit go to implementation. So I was just looking at these like arguments to find one that was like simple. So the first one was the simplest one I could find, which it just takes in a nullable entity, so I just pass null to it because we don't need more, and then a position and an explosion player. So you're just gonna call that function inside your event, which is what it looks like this. So you can just copy my code here.
So if I want to find the function that kills the person or like kills the player,
Yes.
then
So the way I would do that is, so we don't have a, get entity is how you get the player. I would just start typing, and look, it's called kill. So yeah, I don't know the names of most things, but you can sort of guess. But if you didn't know the name, then what you could do is you could right click this, go to implementation. Here's player, go to implementation, right? And then there's a bunch of different players. You want the server player probably, since that's the one that has all the logic. And then I would just search for like die or something, you know? Here's the die function. That one's not really helpful. So the thing with kill is it's not just players that can die and like be killed. It's actually all entities. So like what you'd actually look for is it's on LivingEntity is the death. So not all entities are living, like they can't die. For example, a boat, like a boat that you can place, that's an entity because it's a movable thing, it's not a block, but it can't die. So a living entity is something that can die. So if you go to LivingEntity, I want the actual abstract one. Oh, I see. You need to go to declaration because implementation implies that it's not abstract. LivingEntity is an abstract class. So you have to go to declaration or definitions. So this one actually defines the kill function. And what kill looks like is it just does a bunch of damage. So you could also just do the hurt function directly instead of calling kill. But yes, kill is how you would kill the player. immediately. So anyway, has everyone written their explosion or killing or such into?
I was waiting for the radius.
One quick question.
I put 4. What?
If I want to add in a custom sound, where would I store the file?
It would go inside the assets. So it would have to match your mod ID, but if you make resources, in the resources folder, make an assets folder, and then you need one that matches your mod ID inside that, and then you need another one called sounds, and then you put OGG files in there.
Okay, I need to convert and
Yes. Minecraft also, to like actually be able to use the sound, you have to register the sound. Luckily for you, there's a thing called the sounds.json. Here, but if you look at the API documentation, resources, client, sounds, here it is. Here's your solution. NeoForge documentation. Anytime you want to know how to do anything, this is actually a pretty good source. They've stepped up their game in recent years with writing actual documentation. So you need a sounds.json file to define like any sound events you make. Sounds are kind of complicated, but so everyone has their on right click function. It's subscribed.
So I want to double check. What are going to be the functions right underneath?
It doesn't matter where it is as long as you have the @subscribe event and the event bus subscriber, and then it's also static and has this as the only argument.
I didn't clean out the things you said to delete. So what was you said delete?
Okay, your event bus subscriber needs a mod ID in it.
Yes.
So put the mod ID in there. No, don't do that. Just put example mod.mod ID.
Okay. I was like,
I mean, it's the same thing functionally, but it's better to reference that. So you have that. Scroll down to your event. Yes. So you need to put @subscribe event before it. Doing documentation. You are ahead of the sure.
A little bit behind actually. I'm trying to find out how to specifically be able to find whether or not an entity is a player. What?
Why are you looking at the spawn page? Anyway, entity.
Because I'm looking to spawn when a player jumps. I'm looking to spawn a Minecraft entity.
Oh, okay.
Pretty simple.
You do. It's a level dot create entity.
Yeah. The main thing is I want to specifically have it spawn at the player, and one of the things I'm struggling on that I'm trying to do is 2 steps at once.
Events.getEntity.getPose. You have the entity E, right? E has a get pose, P-O-S.
Yeah, I got it.
Yeah.
The thing is, I don't know whether or not it's a player.
It is a player. If you
Okay.
hover over get entity, right? You can see the type that it's returning.
It's a living event. I mean, sorry, it's a living event.
Oh, that's living something. You can do instance of player. If E instance of player. Okay.
Thank you.
What's up? You can also try, there might be a player jump event.
So here, so I got this.
Is that terrible?
So I copied this.
You can just call kill on it. You don't need to copy that.
How do I?
You can just do event.end.kill.
Oh.
Yeah.
Because I tried. Oh.
Yeah. You don't need to copy that.
Cool.
Yeah, and then I see your go up to it. Yeah, that should work. Looks good, right? Need this. Pass the mod ID to it. Same way as add mod.
Oh yeah.
You got it.
Where this file goes.
Yeah, looks great. Everyone. All right. So, looks like everyone sort of got it.
Directly in the namespace.
We're gonna run it now. So if you just hit run, it will recompile with your changes. Oh, I've made a mistake. I put a bracket. Yeah. Oh, I made a mistake. Cannot register listeners for abstract class. Register a listener to one of its subclasses instead. Okay, I see. So player interact event is not actually correct. There is the right-click item event is what we want. So yeah, just do what I just did. So change player interact event to player interact event dot right-click item. Yeah, so if you hover over player interact event, it says that it's fired, but only the subclasses, and it's an abstract class, which means you need a different version of it. Yeah, so there's several different types of interactions. So there's one class that's shared between all of them, but we wanted the right-click item because you could also interact with an entity, you could interact with a block. So these, let's see. Wait, here's what we just found. So the stick, this right-click item event is not fired if you right-click a block with an item. But I'm assuming like we want it to trigger when you right-click a block with a stick, like explode that block rather than just right-click the air and then it explodes. So we want right-click block.
Event bus subscriber needs the mod ID. It's giving me an error.
Mod ID equals put before it inside mod ID underscore. Mod underscore ID equals. That's not correct. I don't know why. Try just no. Yeah. Okay, so everyone's changed theirs to right-click block. And we're gonna boot it up. We're gonna explode stuff. Who's ready to explode stuff with the power of codes?
Yeah.
What if I want like the stick to explode the block and an entity?
We can make another event.
Oh, it's a block.
Yeah, you can make more events. So all right, guys. Now's the moment.
Will it work?
Will it work? I'm gonna go in survival just for fun. Oh! It didn't do any damage. So I'm assuming this is actually a client server issue. Hold on. There's no like time delay on it, so it just keeps exploding. So you'll notice the world actually isn't getting blown up. That is so. No, explosions. So explosions are a little weird. They run on both the client and the server. I haven't actually gotten to client-server separation, but it's actually a really big deal with Minecraft. Like networking is very important. So, it's gonna be like more in detail in later lectures and stuff. But the client, like the server, is in charge of everything, right? But the client is the thing that actually does stuff. So like the server has to agree with the client that you blew up those specific blocks. So like, I think the problem is the server just isn't getting informed, or the client isn't. Hold on. So if I reload this world, I'm gonna bet that the ground. Weird.
I got an arrow.
Awesome. So if you go to the server level,
I got an arrow when it loaded.
explosion.
Yeah, this is fun. The legal argument exception.
Ah, I figured it out. So the reason that nothing was getting exploded is because I put the type as trigger. I think the type needs to be block. Or maybe TNT, which is both. Yeah, so I'm going to try a different explosion interaction. I think that should work. So the one downside of modding is every time you make a change, you have to restart your game.
This was what I was gonna ask about.
Yeah, so there is a very limited capability of hot reloading if you run it in debug mode, but it is very finicky and it doesn't work well with multi-loader stuff. I think it should work with NeoForge to some extent, and I think it works better if you have IntelliJ Ultimate. I think that's the one upside. What?
I don't know what's going on here.
1 second. Boom! Look at that. We have a hole in the ground. Look at that. Isn't that awesome?
That's awesome. Wait,
So you've seen this illegal argument exception came out with the class. Oh, I think I understand. Damn, okay.
Yeah. What did you guys do? Hold on. You need to make a language event. Hold on. They're a little weird. They're called text components, I think. Yeah, so you need new string component, I think. They might have renamed. It's component.literal. And then you are dumb. Yeah, so this would be how you would send a message. You have to send so the way the reason this is the way it is, you have to send a text component. The components, Minecraft is localized obviously, so every single piece of like language text is actually written. You send a language ID, so what you would actually send is a translatable, and then it would be like lang.minecraft.deathbyidiot or something like that. And then you would open your language file inside here and then define a new like entry for that key, and then like each language would have its own version. That's how you do localization. But for Minecraft mods, if you just want it in English, you just put literal and then some text. And then that would send a message. You can also do fancy stuff with this, like make them like red and bold. What's up? You don't have the components?
That's it. I don't need to close Minecraft for Apple testing because it will just crash eventually.
Hey, don't mess with my Minecraft.
What?
What's up?
Wee.
Yes. Get your own. Does yours not run?
Actually, it does. Just only for a few minutes and before it crashes.
Let's see. It is net.minecraft.network.chat.component.
What I actually wanted to see was the line that you changed to. Yeah, thank you.
This is the one you need.
That was. I think I got it now. Let's see. Did you do it?
Oh, you're typing it down on your phone?
Does it work?
Yeah. You got it? Yeah. Tell them and then send a message. How do?
Why isn't this not playing?
Send system message? Yeah. It's
Oh, so the reason it's sending twice is actually, so that event is dispatched on both the client and the server at the same time. So your client is receiving the event and executing it, and the server is also receiving the event and executing it. So what you can do is do
No, it
events,
becomes
if events.get level dot like is server or something, you can check if this level is like a server level and only send it twice through. And then like is server is unaccepted. So yeah, do not unaccept. And then yeah, now it'll only send one. So yeah, sidedness is really complicated in Minecraft. It's a big part of modding, and we will go deeper into that also in later lessons. Hooray.
sound I'm trying to use as a plugin for some reason.
Did you make a sounds.json?
I did.
No sound event?
I did. It's here. And
You have it on screen. Is that a big sound?
it's like a couple seconds.
Finish. That's string for metal type sounds.
Yes.
So, okay, in asset structure test sound, you made a sounds.json.
It's supposed to make this class.
Can you see the sounds.json? See the class?
I went based off of the.
So you need to register your deferred register as like it needs to get class loaded basically.
Is that what it does?
I saw the best, yes. It's registered to mark also you see the metal type. Your sound event and the name is my sound.
No.
So are you calling it? Where are you calling it? Yeah, I think the ID is wrong. That's it. The my sound is the actual one that sounds like JSON. It's the one that sounds like JSON.
Metal pipe.
I think that's the. It's also hold on. Go back to metal type class. That. Not the name. The name doesn't matter.
And the mod. The mod.
You should be using the. Referencing that. Hand typing it. It's better that way.
I make a big static file for every Minecraft block.
Yeah.
And so the behavior is way up there. So like the items
What are you looking for the behavior of?
just the TNT explosion.
Oh, you shouldn't be looking there. You should be looking for TNT block.
It'll be like
So it's a.
Oh, but are you
So
passing
yeah,
it
the
on
logic is
the
usually in a class
register?
that's associated rather than
Oh,
the entry or the TNT block.
Alright, let's see.
I can't wait for the metal pipe sound.
No, it should. No, I think that's. No, I think we're good.
Alright, I think that is all for my official lessonry. We did a thing today. It's very cool. I'm going to end the recording, but I'll be around.
No, you have to do.
Thank you all for coming, whoever's on virtually. Much appreciated.
Or